My name is Keshwani. That's Keshwani. Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, the official guide to the revised GRE, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 229. Please turn to it. Page number 229, and today is our lesson number 319. These problems that you see there on page number 229 are the exact same problem that appeared in the first edition of the revised GRE. We have already solved every single problem from the first edition. If you're interested in watching the original solution to this particular problem that we're about to do, you will find it on day number 107. Today, right now, we're going to do the exact same problem again, but at a faster pace. So if you need more help, if you need to do it slowly, if there are some concepts that you think are just brushed off, then watch the original video, as I said, which is a little bit longer one. Now, 2.6.2 is what we're doing here. Now, before we actually solve the problem number 2.6.2 on page number 229, let's start with something simple, something very basic. Here's the question. How much is square root of 4? How much is the square root of 4? Sounds like a simple, silly question to ask. Everybody knows what the answer is. What's the square root of 4? What is this question asking? What the question is asking here is, what is that number which, when multiplied by itself, gives us 4. And you know the answer? Of course you know the answer. Actually turns out that here we do not have an answer, we have actually two answers. There are two such numbers which, when multiplied by themselves, give us 4. And those two numbers are, of course, positive 2. Positive 2 times positive 2 is going to give us positive 4. And negative 2 times negative 2 is going to give us positive 4. Therefore, the square root of 4 equals positive 2 and negative 2. Now, mathematicians do not write like this. They do not write them like this, positive and negative 2. This is how we're going to find it in the math textbook. In the math textbook, we said the square root of 4 equals positive 2 and negative 2. This is how we write it. So in fact, there are two answers. So this question, the way it was phrased, is technically speaking not correct. It's not correct because it is written in the singular. It should have been written in the plural form. What are those numbers which, when multiplied by themselves, give us 4? And the answer is there are two such numbers, positive 2 and negative 2. Now let's do one more. Let's see what happens. We're going someplace with it. Let's do one more. Here's the next question. Can you think of a number which, when multiplied by itself, is going to give us negative 4? What number, or let's phrase it in the same way that we did before, which is, what is that number? What is that number which, when multiplied by itself, gives us negative 4? Can you think of any number? And the answer is, well, you see, in order for it to be a number, any number, a given number is going to be either negative or positive, other than, of course, 0. Because 0 times 0 is 0, obviously we're looking for negative 4 here. So a given number is going to be either a negative number or a positive number. Obviously, those are the only two possibilities. What else can a number be? If the number is not 0, then it's got to be either a positive number or a negative number. Now if it turns out it's a positive number, then in this case, positive, a number times itself, positive times positive is going to be positive. And if it turns out it's a negative number, then the negative times a number times itself, negative times negative, is also going to be positive. So it is not possible. It is not possible for a number such that when you multiply it by itself, it gives us a product of a negative quantity, a negative product. It is not possible. What is that number which, when multiplied by itself, gives us negative 4? The answer is no such number exists. No such number exists. In other words, we can't have negative quantity. We can't have negative quantity under a square root sign. We can't have a negative quantity under a square root sign because it is not possible to take a square root of a negative number. Now let's look at next question, shall we? Let's do next problem. Here's the question. We are told that y equals square root of x plus 2. Ask ourselves, when is this quantity under the square root sign going to become negative? Because we can't have a negative quantity under the square root sign. Here, this quantity here, the quantity under the square root sign will become negative if x happens to be less than negative 2. If x happens to be less than negative 2. If x is negative 3, negative 3 plus a 2 is going to give us a negative 1. We can't have a negative quantity under the square root sign. Can x be negative? Can x be negative 2 itself? Can x be negative 2? We just said it has to be less than negative 2. Can it be negative 2? The answer is yes, it can be negative 2, because if x happens to be negative 2, negative 2 and a positive 2 is going to give us 0, and of course square root of 0 is 0. We can figure out the square root of 0, square root of 0 is 0. But x cannot be less than negative 2. Now how do we say this thing in the language of mathematics? This is how we say it in the English language. It says here, the quantity under the square root sign will become negative if x happens to be less than negative 2. Therefore, we continue this thing. Therefore, x is not allowed to be less than negative 2. This sentence that we just wrote down here, that x is not allowed to be less than negative 2, x is not allowed to be less than negative 2, now we're going to say the same sentence in the language of mathematics. Now it is very important that you have watched yesterday's video, day number 318. As I always remind you, that it is important, it is vital, it is crucial, it is imperative that you watch these videos in sequence, because sometimes the concepts build on each other, and I don't have a luxury of obviously repeating every single thing, every single video. It will never end otherwise. Yesterday we spent a great deal of time learning the concept of a function. What is a function? What is domain? What is range? You have to understand those terms, because I'm going to use those terms right here. So how do we say this thing in the language of mathematics? X is not allowed to be less than negative 2. In the language of mathematics we say that that the domain of this function I'm talking about right here, this function right here, domain of this function, the domain of this function here is x greater than or equal to negative 2, 1. The domain of this function is that x has to be greater than or equal to negative 2. X cannot be less than negative 2. X is not allowed to be less than negative 2 x is not allowed to be less than negative 2, in the language of mathematics we say the domain of this function is x has to be greater than or equal to negative 2. That's all there is. Now let's do the problem that is in front of us, which is 2.6.2, which is the actual problem that we have to do. I need the room obviously, so I have to erase stuff. The function that is given to us in 2.6.2, I believe it is 2.6.2, looks something like this. G of x, we are told, equals x cubed plus x plus 2 minus a 10. Is there any limitation on x here? Is there any limitation or limitations on x in the first term? These are called terms. This is the first term. The answer is no. If it's simply x cubed, x can be anything that it wants to be. There are no limitations here. X can be negative, positive, 0, whatever the hell it wants to be. There are no limitations here. Is there any limitation on x in the first term? The answer is no. The answer is no. Another way of saying the same thing here would be, in other words, had it been simply this part here, gx, if we were told that gx equals x cubed and nothing else, in this instance we would have said, we would have asked ourselves, is there any limitation on the x here? The answer is no. Another way of saying the same thing is that the domain of this particular function is all real values of x. But unfortunately, we have more to it than that. The second term is this part right here, which is x plus 2. The square root of x plus 2, and then we have a negative 10. Of course, negative 10 plays no role here because x doesn't even appear in there. It's a constant term. So we have to ask the same question here. Is there any limitation? Is there any limitation on the second term? And the answer is yes. What is the limitation on the second term? The limitation is that x is not allowed to be less than negative 2. X cannot be less than negative 2 because if x were less than negative 2, we'll end up with a negative quantity under the square root sign. This quantity will end up becoming a negative quantity, and we'll end up have a negative quantity under the square root sign. We cannot have that. Therefore, the domain of this function is the same as the domain of the previous function that we wrote down, where it was simply square root of x plus 2. So here, even though we have three terms, x cubed, square root of x plus 2, and a negative 10, even though we have three different terms in this function as opposed to the previous function that we did, even though there are three terms here, but only one term that actually plays any role here in terms of determining the domain of the function, which is this term right here. So the domain of this function is, again, x has to be greater than or equal to negative 2. That's all. I'll see you tomorrow, okay? Bye now.